Hey guys, today I want to show you some quick and easy tips for saving immediate cash via changing some ways you do things with your electrical devices. Now this is specifically geared towards anyone that does a lot of computing work. That might mean you're a gamer, it might mean you're a photographer or a videographer, but really these things can apply to anybody that pays a power bill. What I have here is a device from a company called P3. It's called the Kilowatt EZ. These are available for under 30 bucks at Home Depot, Lowe's, even some Walmarts. I've seen it online for about 20 bucks. There are cheaper brands out there, cheaper versions. I've seen one for a few bucks less from Ryobi, and there are a couple models that are a little bit different that have like an extension cord, but this really gives the most data and it's not that expensive. So I would recommend getting this particular unit if you want to do what I'm going to show in this video. Now there is a way to do what I'm going to show you manually, but it does require a multimeter that is about the same price as this and destroying some power cables. So this is why I'm going to show you this way. Basically what this device does is it plugs in between your wall and whatever device you plug into it, and then it measures all the electricity flowing through, and it gives you all kinds of cool data. It tells you the voltage of your house at the moment, it gives you how much power that device you have plugged in is using, and it can calculate, when you put in how much your electrical cost is, it can calculate how much money that device costs you per month, per year, and I believe it even does per day. So what you can do is use that information very quickly to possibly alter how you are using devices or when, and immediately save some cash. And it's a real eye-opener with some other stuff which I'll go into later in this video with certain things such as battery chargers. Now this device, and just one quick thing about electricity in general before I start, a lot of people have absolutely no idea how electricity works. It's really simple once you just understand the easy, quick terms. I'll put it into the analogy of water, which I think everybody can follow. Electricity is just like water as far as how you measure it and how it actually works. With water, say you've got a hose, a garden hose connected to your house. You've got a certain pressure coming in from the water company. And you know that varies a little bit. If you've ever been in a hotel, say, where everybody's taking the shower at the same time, the pressure can certainly drop during peak times. But for the most part, pressure is a constant. So electricity has the same kind of thing. It has a pressure. It's measured in volts. And that voltage is, again, regulated by your electrical company. And it's going to range between 110 and 120 volts. Now that is going to fluctuate just like water pressure as demand and time of day changes. You'll see it fluctuate, and this will show you at the moment that we're reading it exactly what the voltage is in your house, so we can get so it uses a very accurate calculation. But if you're doing this manually, you can just pick a middle of the road and use 115 volts for your calculations. That's a real good average. Now another thing to consider that I'll talk about a little bit later is battery backup units, and I use those on every single major electronic device in the house, not for the battery backup, but simply for power conditioning. Sorry, I couldn't think of the word there. I live in Florida. It's a horrible power grid. We have lots of storms, lots of lightning strikes. The power here goes on and off a lot, and just normal line fluctuation is very bad. It's very dirty power here. So I use the battery backup units more as a buffer for all my electronic devices, my TV, computers, printers, networking equipment, everything. Bedroom, office, living room, everywhere. Everything goes through a battery backup unit. If I could afford it, I'd get one of the whole house units just to isolate myself, but I don't. So anyway, just like the water pressure coming out of your house, we have voltage, so that's pretty much a constant. Now say we have a garden hose and we put a nozzle on the tip, like we're going to wash our car or water flowers. It restricts the flow, so you got a smaller stream, same pressure, water's still coming out of the same pipe in the house, same pressure, but a much reduced flow. So the flow rate is reduced. The flow rate in electricity is measured in amps. And the amps is what this is going to measure. It's going to measure the flow rate of the electricity coming through to the device, and it's going to calculate how much electricity we're using. Now, if you can think about that not only between the nozzle and the garden hose. Say you've got the nozzle on, okay, that's a certain flow rate. Say you're filling up a swimming pool. Would you do it with a little garden hose nozzle? No. You take it off and just let the hose dump into the swimming pool. It's going to fill up a lot faster because you've got a lot more flow rate. Well, imagine if you used a fireman's hose. Even bigger. It's going to flow a lot faster. It's going to fill the pool up even more. So the flow rate in electricity as amps is just like water. The more amps, the faster the flow rate. Now, how much water is coming out total, that's measured in things like gallons. You know, you've got a big swimming pool, it's measured in gallons. Well, the total amount of electricity, if you could pool it and measure it like that, is called watts. Watts are simply how much electricity has accumulated or come through or been used. It's an amount, it's a calculated number. And to get it, you simply multiply the volts times the amps. And you get watts. Watts is important because this is what we're billed for by the power company. We're paying for how much electricity we're using. The voltage, which is about a constant, times the amps, which is controlled by whatever we plug in, how many amps it actually uses, equals how much electricity we buy. Just like water. The pressure from the water company is about the same. How much water, you know, if we have a sprinkler system or if we're just taking showers, if we have a lot of laundry to do, we use different amounts of water, equals how much water we pay for. So the same thing. Now the measurement from the power company is measured in kilowatt hours, kWh. And if you go out to the meter on the side of your house, if it's the old analog kind, you'll see the slow spinning disc, and it's counting down how many watts you're actually using at that moment. If you have a digital unit, you can't really read most of those, but basically it's tracking how much electricity we're using. And to figure out how much it actually costs us, you have to look at your power bill, or you might have to contact your electrical company, you might have to go on their website. The rates can be a little confusing because everybody's going to be different. You might have 2 or 3 different power companies available in your area. It might vary by county, by city, there might be surcharges. So really pull out your power bill. Also, it's going to vary in most cases by time of day. You're going to have, just like in the old days, kids, you might not know what I'm talking about, but remember when we had long distance charges and there were different rates depending on the time of day? Well, most electric companies still do that crap, and basically they have peak and off-peak hours. Cell phone plans used to do that too. Basically, sun up to sundown, you're going to be paying a lot more than after the sun goes down. In my case, it's almost 4 times as much during the day as during the night. So I'm paying about 15 cents a kilowatt hour. So what I did is put that rate in here. This device allows you to just plug in your rate, so it will use that in its calculations, and it shows you real time how much electricity is being used, and depending on what rate you put in, how much money it's actually costing you real time. So that's kind of cool here. But again, if you have a multimeter and you want to splice your own cable, basically you're just going to splice your 2 multimeter leads into the hot cable and plug that in line with your device. You can just read on your multimeter how many amps it's using and do your own calculations. It's simple, but it's a little messy. This is a lot easier, and it works with any device, any kind of cable. You don't have to destroy anything. So that simple electricity, you're going to be measuring how many watts so you can figure out how much you're being charged and spending. And we're going to be taking a look at a bunch of different devices: computers, monitors, networking stuff, battery chargers, basically whatever I can find that I think is going to be relevant to everybody, and we'll see exactly how much power everything draws. I'm going to do testing at different speeds of the computer, things on standby. We'll see what happens, and we'll see what kind of changes I can make and maybe what kind of changes you can make to save some cash. Alright, let's get working. Okay, here we have a real common device. This is a AA battery charger. Lots of people, especially photographers, are going to have these. I use these in my flashes, my speed lights, lots of different studio equipment. So I'm constantly using battery chargers, especially the AA. Now, this is in standby mode. I am not actively charging. You can see it's empty, and it's pulling a measly little 2.2 watts. Barely anything. At my current rate of 15 cents per kilowatt hour, even during peak hours, that works out to 0.008 cents per day, or just under $3 a year if I left this plugged in 24/7 and it was all billed at that high day rate. In reality, my rate is about a quarter of that at night, so this would be a little over $1 a year if I wanted to leave this plugged in all the time. So this one gets a seal of approval, A-OK, if you want to leave your normal battery chargers, including your camera battery chargers. I'll go ahead and plug this one in just for kicks so we can verify, but I'm pretty sure it's going to be about the same or less in standby mode. Let's see. Okay, I've got the Canon battery charger. This is the latest model for the 5D Mark II, 5 or 7D, all the normal stuff, and we're reading 0. So in non-charging mode, this Canon really goes into a standby mode and it's non-functional, so that's perfect. Let's go ahead and plug in a Canon battery and we'll charge it up, see what kind of readings we get during charging, just for kicks. So I popped in a Canon LP-E6 battery and it's currently showing about a 50% charge, so it's in full charge mode, maximum power, and it's only pulling about 12.8, 12.7 watts. Which again is absolutely nothing. Even if you were charging batteries 24/7, constantly swapping them out so they're at full charge, even at full day rate, which doesn't exist, you would only be spending less than $20 a year. So very efficient battery chargers, no problems there, using anytime you want. Now we're going to kick this puppy in high gear and charge 8 AA's at the same time. And like I said, this is a slow charger, which is much nicer to the batteries than the fast chargers, and it's pulling a measly 3.5 watts, barely above what it was on standby mode. So again, almost free to use. Fast chargers are going to use a lot more energy, but they are going to charge much quicker. This takes 6 to 8 hours for a full cycle of discharge, conditioning, and recharge for all 8 batteries at the same time. Fast chargers can do it in, I mean, some are as quick as 30 or 60 minutes. They generate a lot of heat. They usually have their own cooling fans. They operate so hot, but they do pull a lot more energy. So that's it for battery chargers. Basically, modern battery chargers, good to use any way you want, anytime you want. No effect. Okay, now I have the unit plugged in and running my computer. Now what I've done, because I've just built a new computer and I've done a lot of special things to it that directly affect the power consumption both up and down, what I've done for this example right here is put it back to stock. You can see it's running at just over 3,400 megahertz, which is stock for this chip, and it's just sitting here idling. This is the way it's going to be running any kind of normal office stuff, you know, surfing the web, email, chat, Facebook, whatever. Nothing intensive, nothing like real heavy-duty photo editing, video rendering. Even photo editing is not going to push this up that much, because photo editing just does a lot of peak usage. It's not constant. So this is a real accurate reading of what I'm going to get for normal day-to-day use just from the computer. It's not including the monitor, which I'll measure separately in a bit. But this works out to, if I'm just calculating 8 hours a day during peak, so just daytime usage, like if I was just working in any office with just this computer, that calculates out to about 14 cents a day just for the computer. Now, I've done some things to this. I have really sped it up, so what I'm going to do is put my settings back to the way I have it configured, but what I've also done is utilize power saving modes. What this will do is when it doesn't need full speed, like when I'm not rendering video, it actually ramps down to 1.6 megahertz, or gigahertz I should say. So that's going to hopefully save me some money. So I'm going to do that. I'm going to put my settings back to the way they were. You know what, actually first I want to fully max this out just out of curiosity. I want to see how this performs stock if I fully max out the processor. So I'm going to fire up Prime 95, which is a benchmarking program, and it will stress the processor to 100%, and we'll see how that affects the power consumption. So here we've got Prime 95 running, which runs these mathematical calculations, and it's used in this case just for testing purposes. And you can see that it's maxing out, focus on that, CPU's pegged at 100%. So it's sitting there in a stock out of the box configuration, pulling 175 watts. So it's a good boost, not that much different, a few cents a day at most, if this were pegged at 100% rendering video. So now I'm going to go ahead and put my settings back to the way I set up the computer, which is dramatically faster, and we'll see what effect that has. Okay, here you can see I put the settings back to the way I configure my computer, and like I said, I've done things that affect energy usage both up and down. Down to save cash, because most of my work is done in this idle state. Browsing, Facebook, email, normal photo editing, normal stuff. I have the computer set to ramp down to save power to 1.6 gigahertz. What's that done? It went from just under 120 watts before, stock out of the box, like most computers are going to be, down to 90, 89. That's 30 watts less. That's 20% savings slashed off my power bill just from changing my computer settings to alter my low power state. Bam, easy. This can also be applied, and I actually run a piece of software that does the same thing on my laptop, not to save money, but to get more battery life. Because like my desktop computer, when I'm doing stuff on my laptop, I'm not doing heavy work, I'm doing normal stuff. It's not using the full processor, so you don't need it. Most computers are not going to have this feature. This is pretty recent, and it does take someone that knows what they're doing to set it up to work effectively. But if you have the capability, if your motherboard and processor support it, this is a great, easy thing to do to immediately slash, in this case, 20% right off the bottom line of your power bill for your computer. And during peak rates, that can make a difference. So what I'm going to do now is crank this up to 100% again using my test software. Let's go ahead and do that. And we'll fire up, launch it correctly, and we'll fire up 8 tests. We'll load the CPU up and wait for it to load. There we go. Now we're setting it 100%, so it's using full power. We were at, 170 before, and now we're at just under 230. So it is a significant speed boost, and it does come with a power crunch. So when am I in this state? This is when I'm rendering video. Now I don't do a lot of video. I do have the Cigar Obsession video cigar review site, and I do a lot of video for that, but it's not heavy duty. If you're a videographer, obviously you're doing hours and hours and hours of this. So this is something that affects your power bill. So it's just a good measurement so you can see the difference between idle states and rendering states, both on a stock and a really tweaked out computer, so you can see the difference in the cost savings. Now let's see, what else can I do? Oh, I can fire up the GPU. This will appeal to gamers, and you know what, to an extent, videographers, because a lot of popular video editing software such as Premiere and the latest Sony Vegas can take advantage of what's called CUDA technology. Basically, if you have a late model NVIDIA video card, the software can take advantage of its processor, just like the central processing unit, and give you multiple times boost in performance for rendering your videos. I mean, it seriously can cut your rendering time by 75% very easily by putting in a good video card and using the right software. So let's go ahead. My GPU is sitting at 0%, and I'm going to run a video test here. So this will max out my GPU at the same time I'm maxing out my CPU. Wait for this to fire up. Takes a second because it's obviously being completely used by the other testing software. Did I click it? Let's try it again. Let me stop one of these CPU tests. Stop two of them. Might be conflicting. Okay, yeah, there we go. I was trying to fire up two. It was just lagging way behind because it was being used. Okay, so now our GPU pegged at 99, or effectively 100%. We've got this graphic running here. This is what's crunching the GPU, the graphical processing unit. So it's cooking. And that uses a lot of electricity. The heavy-duty cards can use 200 to 300 watts per card. I don't have a top-of-the-line card in here. This is a 560 Ti, which is overclocked about 30%. So it's effectively like a 570 card, which is, well, as of today, third from the top of the line. Used to be second from the top of the line. And you can see up here it's registering as the 560 Ti, and temps are 63 Celsius, well under the thermal max. I'm running a core clock of 955 megahertz and memory clock at 2143, so a significant overclock. And let's see what our power is doing. Remember, this is also pulling the CPU, and wow, that's actually impressive. That's only at 370 watts. That is really good for what this system is doing right now. This is running at 4.6 gigahertz on the processor overclocked, and just under a gigahertz on the GPU overclocked, maxing out at well under 400 watts. That's really cool. So that leaves me plenty of power for other video cards if I want to put in there. If you're a videographer, you can put multiple cards in and get even more processing speed. If you're a gamer, obviously you're probably going to be running multiple cards anyway. So that's cool. Alright, and actually in computers you can actually affect this number directly by choosing the correct power supply, because they have efficiency ratings. Basically, you want to match your power supply total wattage to approximately as close as you can get to what your computer is actually going to be pulling. I have a 750 watt power supply in it right now, but I also have 4 hard drives, an optical drive, some fans, so I want a little bit of headroom. But if I were to, say, put in a 1200 watt power supply, I would be wasting power. I would be actually drawing a little bit more, because it would be running at less capacity and therefore less efficient. So you want to match it as close. I could probably put in a 550 in here and even drop this number a little bit more, because it would be a little bit more efficient. But I'd rather have a little bit of headroom to save pennies a year. So that's pretty cool. Fully maxed out, or well under 400 watts. At 375 watts, just to round it a little bit, that calculates to 8 hours of peak running at 57 cents a day. So really not bad at all. Here we have everyone's favorite entertainment device, the DVR box. This is pretty much going to be the same whether you have a cable provider box like I do, or a satellite provider, or a TiVo, or whatever. Basically, they're low power computers with a hard drive and cable tuner card. This is currently off, and it's pulling about 25 watts. Let's go ahead and turn it on. And now it's on default channel. Surprise, surprise, no change. That's because DVR boxes, and most cable boxes, never actually shut off. All you're doing with the power button is defaulting back to the channel and turning off the video output, which doesn't really cost any power. These things are huge power sucks. So this thing is sitting here 24/7 drawing 25 watts whether or not you're even watching TV. So what's the moral of the story here? If you're not using a cable box, if you have one in a guest room, if you've got one out in the garage or wherever, and you're not actually watching TV, unplug it. You're just throwing money down the drain. Here I've got plugged in the actual Alien B AB800 studio light, and it's obviously just running the modeling lamp, and it's pulling in a cool 120 watts. This is obviously going to depend on what intensity you have the modeling lamp at and what size bulb you have plugged into each unit. Multiply that by however many hours you're using it and times however many units you're using. So that's it. I hope you've learned a little bit about electricity and picked up some tips on how to easily possibly save some money on your power bill depending on your home or office setup. Obviously these tips and savings are going to be compounded by the number of hours you're working, number of systems you have. If you're in a large office environment, this stuff can add up really quickly. Obviously if you're just somebody sitting at home and you're doing a couple hours of work a week on your computer, it really doesn't mean anything. But if you're operating a photography studio, if you're operating a videography studio and you've got multiple people and cams and computers and workstations and everything, this can really add up. So take a look at what you've got running, modify what you're doing, maybe put on some new software or alter your hardware and save some cash. All right, we'll see you next time.